All right, welcome back. We are now moving on to Philadelphia. I've typed the data into my stat edit on my calculator. I was also able to type it into Desmos as well. And looking at the graph, I see it looks like this, where it again has a maximum in the summer and a minimums in the winter. Quickly, we're going to find the max and min down here, number 11 on page 55. The maximum, we're going to do second trace, 4 for maximum. I want to scroll to the left and hit enter. Scroll to the right, hit enter twice, and this will find the summer solstice, which will be about 172,894. And again, that's day 172, which we can use this chart here to figure out is 20 days after June 1st. So that means it is June 21st and 894 minutes, which seems like it would be about 14 hours. Let's see, 894, 14 hours times 60 minutes is 840. 894 minus 840 gives us 54 minutes. So it's about 14 hours and 54 minutes. The winter solstice is going to be the minimum. So the minimum, we'll go back to our graph, second trace, find the minimum. It's going to be over somewhere in December. So I'm going to hit enter when I'm to the left of December. So it's in maybe July there. Scroll all the way to the right. Once we've hit zoom 9, it won't let us go any further than 368.4. And that tells us a minimum of 360. Let's run this to 361. And then 558 minutes. So a little under 10 hours there. So that's day 361, which day 361 is how many days after December 1st? It's 26 days after, so that would be December 27th. And then 558 minutes is approximately 9 hours. Let's see how much more than 9 hours it is. 9 hours times 60 minutes is 540. 558, take away 540, and 18 minutes. But we kind of did that last video as well. What we really want to see are the differences between Houston and Philadelphia, and we also want to find the intersections and like how the max daylight and minimum daylight compare. So on Desmos, I have both of these drawn. So this kind of less different line here, this whatever color line this is, green maybe, this is Houston, and then the darker line here, the black line, is Philadelphia. So you can see that it has higher extremes. So the extremes are further, so the maximum length of daylight in Philadelphia is higher than the maximum daylight in Houston. And we can see that in our maximum values as well. So our maximum value here was 894. There's almost 15 hours of daylight versus on the maximum day in Houston, there's only about 14 hours of daylight. So Philly has a longer summer solstice. And if you notice in the winter solstice, it goes from 9 hours and 18 minutes for Philly, and then 10 hours and 14 minutes, almost an extra hour of daylight, and the shortest day of the year as well. And this is because Philly is further away from the equator. It's further away from the equator. So in the summer, Philadelphia is tilted closer to the sun, so it gets longer exposure to the sun. And in the winter, it's tilted further away from the sun, so it gets less exposure to the sun, where Houston kind of gets a little mid-range. It only goes from about 10 hours to 14 hours every year. Next, we want to look at the intersection points. So moving on to page 56. We have the intersection points. So I'm going to show you on my calculator. I have both. There's Houston being drawn, Philly's already drawn, and Houston's being drawn there in the blue. So we can see that twice a year they have the same length of daylight. So we're going to go find that by hitting second trace 5, and I'm just going to hit enter, 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 and it'll go find one of the two intersection points. So I'm just going to sketch this real quick. So here's Houston, here's Philly. So this intersection point right here is 77, 725. So that's on the 77th day, so day 77, which we'll then use our chart on the previous pages. Day 77 looks to be 17 days after March 1st. So that'll be approximately March 18th. And 725 minutes. That is 12 hours and 5 minutes. So on March 18th, which just passed, they'll have approximately the same amount of daylight, which is approximately 12 hours of daylight, 12 hours of night. There are two intersection points, so we got the left one, so we need to go find the right one. So we're going to go second trace 5 again, and before we can just hit enter, 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 we have to scroll all the way to the right, so we're close to that second intersection point. Enter, 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 and we got 267, 725. So that's 267, 725. So day 267, when we go back to our chart here, is about 23 days after September 1st. So somewhere in later September. So day 267 is September 24th approximately. And that 725 minutes again tells us that there are about 12 hours and 5 minutes of daylight. So 12 hours out of 24 hours is about half. So we got about equal daylight and equal nighttime, and that is called an equinox. Equal night and day, equinox. So we have the spring equinox, happens in the first part of the year, and we got the fall equinox in the second part of the year. Hopefully you can practice this on your calculator in Desmos, and we'll come back next video and wrap it all up.